Most of the world's ancient epics are archived strictly as metaphorical literature. We treat the Iliad or the Norse sagas as moral maps, brilliant stories meant to guide the spirit, but rarely expected to leave a physical, verifiable trail in the dirt. Ramaswaram is the exception. On this small island off the coast of Tamil Nadu, the geography itself seems to have been authored by the Ramayana. The site presents three distinct anomalies that challenge standard coastal logic: a 48-kilometer underwater bridge, rocks that float on the tide, and a massive granite temple complex built on a sandbar completely isolated from any mountain range. We have to ask if modern scientific data can account for these features, or if the physical evidence actually reinforces the details of the ancient text. Ramaswaram forces us to confront the exact coordinate where verifiable geology meets divine mythology, creating a landscape that challenges our conventional understanding of ancient history. Ram Setu, or Adam's Bridge, is a 48-kilometer chain of limestone shoals visible from space. In 2002, NASA satellite imagery confirmed the scale of this structure, which stretches across the Palk Strait to connect India and Sri Lanka. One of the central claims of the epic is the use of stones that could float. Geology provides a physical candidate for this: pumice. When volcanic lava cools rapidly in the presence of air or water, it becomes a lightweight, porous glass filled with trapped gas. However, Rameshwaram sits in a volcanic vacuum. There are no active or historic volcanic sites anywhere in the immediate region, leaving the origin of these stones as a primary point of investigation. The timeline is where the data becomes difficult to reconcile. Carbon dating indicates these stones are 7,000 years old, yet the sandbar they rest upon is only 4,000 years old. In a natural sedimentary process, the oldest materials are at the bottom. This 3,000-year chronological inversion suggests the stones did not originate on this sandbank, raising significant questions about how millions of tons of older rock were deposited on top of a younger geological feature. The Rameshwaram temple houses 22 tirthams, or sacred wells. Even though the temple is surrounded by the salt-heavy Indian Ocean, the water in these wells is perfectly sweet, cool, and rich in specific minerals. Ancient scripture records that Lord Rama created these water sources by striking the earth with his arrows to sustain his army. Hydrogeologists have a modern map for this phenomenon called a freshwater lens. As rain falls on the island, it filters through the permeable sand. Because freshwater is less dense than the salt water below it, it forms a buoyant bubble, or lens, that floats on top of the heavier seawater. While science maps the physical mechanism of the water, it also confirms that the ancient writers were documenting a genuine physical anomaly. The text accurately identified a rare source of life-sustaining water in a location where the surrounding environment suggests none should exist. The temple itself is a 15-acre fortress of stone, heavily expanded by the Pandya and Sri Lankan kings during the medieval period. Its defining feature is the outer corridor, the longest pillared walkway globally. Lined with 1,212 precision-carved granite pillars, each 23 feet tall. This engineering presents a massive logistical problem. Ramaswaram is a sand island containing no local granite deposits. To build this, millions of tons of heavy stone had to be quarried on the mainland, transported across open ocean via wooden boats, and offloaded onto a shifting sandbar, all before the arrival of modern machinery. This corridor stands as physical evidence of a logistical achievement that parallels the complexity of many modern industrial projects. To understand the resilience of these ancient structures, we only have to look 20 kilometers away at the ruins of Dhanushkodi. In 1964, a powerful marine cyclone struck this thriving 20th-century commercial town. In a single night, the modern settlement was erased, leaving behind a ghost town sinking into the sand. The contrast is clear. A modern town was dismantled by nature in hours, yet an ancient 48-kilometer bridge and a massive granite temple have survived the same coastal forces for centuries. Science provides a clear map for the Sweetwater wells and the physics of floating rock. However, the 3,000-year chronological gap at the bridge and the logistical reality of the temple's construction remain outside the reach of simple geological models. Rameswaram remains a physical archive where the boundaries between ancient engineering, geological anomalies, and divine mythology are not just blurred, they are built into the very stones of the island.